Hi everyone, welcome back to our channel. Today we are going to find the resistance across the nodes X and Y. So this is what the question asked to us. The procedure here is, so you can see here, if you redraw the circuit, so I will be solving this by two methods. First one is method 1. So method 1 is, if you redraw it, so this is one resistor, this is another resistor, and this is short circuited. This is X node and Y node. So now the current will try to flow from X and it reaches this node, and current will not divide in this 1 ohm. Why? Because so already a resistor of 2 ohm parallel to an short circuit is equal to an short circuit. The logic behind here is these two resistors are connected in parallel. So the resultant is 2 into 0 divided by 2 plus 0, which is also 0 ohm resistor. So in shortcut, we generally say that resistor parallel to an short circuit is also equal to an short circuit. So indirectly, the meaning here is, so the current will all the time flow only to a low resistive path. So current will start and come to this node. Current will not divide. Current flows in this short circuit path, and current will come out. So here by method 1, the resistance across X and Y is 0. So this is by general meaning. So this you can understand better. So for example, you are having an bathroom. Okay, so you are taking your bath here. Okay, you have the drain hole here. So when you pour some, when you take the bath, so around some 2 liters of water you have been applied in the bathroom. Okay, so the water will try to travel only to the hole, so water doesn't goes up. So this is nothing but high resistive branch, this is nothing but low resistive path. So current, so this is nothing but the current flows only in this path where we are having low resistor, there only the current flows. So current I'm going to compare with water. So generally if you take the bath, the water will flow directly to the hole, it will not go to the upstream. Meaning here is this upstream is offering high resistance. That's what the general sense. So based on this, I can say this first method is offering an zeroth resistor. Okay. So coming to the second method, how the method 2 is. So method 2 is, when you see the this like an star network, we require an delta connection. Okay. So now I'm going to construct the delta. So this is the shunt branch. Okay, so and this is the branch what I need to connect. So I'm relabeling the nodes as X, Y, and if you need you may mark it as Z. So now I'm connected between X, Y, Z. So I require this shunt branch. Okay, so this value, how to find this value is, this black color resistor is connected between what are the two resistors, which is nothing but 1 plus 0 plus product of these two, 1 into 0 divided by, so to this black the remaining resistor is 1. Okay, where this is also equal to 1 ohm, and here you're going to get one more black color resistor. Okay, so here you are going to get one more black, and what is the value of this? You can see here this black color resistor is connected between these two nodes. One is, first resistor is 1 and second resistor is 0 plus 1 into 0 divided by some, what is, I mean divided by what is the remaining value, 1. Okay, so this is also is nothing but 1. Okay, but when you are constructing this black color resistor, this black is connected between X and Y. So the value of this resistor is, so first value is how much, 1, and what is the another value, 1 plus 1 into 1 divided by 1 into 1 divided by 0. Anything by 0 is nothing but infinity. Infinity plus 1 is infinity. Infinity plus 1 is infinity. So this branch is offering R is equal to infinity. Whenever R is infinity, okay, so whenever R is infinity means this branch is open circuited. offering a resistance of R is equal to infinity. So now we are connected across X as well as Y. So this is the converting the given star to an delta, and already in the network we are having a short circuit like this, and one more short circuit like this is already there in the network. So when you start resolving this again, so here you can see here this short circuit and resistor is parallel, already I told. So this is X, this is Z, this is Y. So short circuit parallel to an resistor is equal to 0 ohm. So therefore short circuit parallel to a resistor, so current will not flow in this branch, current will flow only in short circuit. So that's why we have got a short circuit. Again resistor parallel to an short circuit, again you will get one more resistor, R is equal to 0 and R is equal to 0. So connected across X node as well as Y node. Okay, so if we come to X node, it flows into Z node and comes to Y node. So therefore the resistance across Rxy is equal to 0 ohms. So if you do by method 1 or if you do by method 2, the answer remains same. So very simple, the current will flow only in low resistive path than to any resistors connected in the network. So this is a simple sense. This is, if you got confused, if you convert the star to delta also, there is a possibility you'll get the same resistor. Very simple to understand. I am comparing current with water. So for example, same 10 liters of water discharged for a time of 1 second. So 10 charge carriers flowing in a time of 1 second will develop a current of 10 ampere. This will develop 10 liters of water discharge. So when you take the bath, automatically water will go into the hole. It doesn't goes up. Okay, which means that this branch is offering the water flow, this path is offering low resistive and this path is offering high resistance. This is how to generally apply the circuits to your general sense. Okay, hope you are able to understand. If you feel the content is useful to you, please like the video, please share with your friends. If you have any doubts, let me know in the comment section. And if you're watching the channel for the first time, subscribe to the channel. This is a free channel for the development of students and faculty. Okay, hope you understood the problem clearly. Yours Ram.